Hi, my name is Thomas Wilson and I'm a challenge participant, and today we're going to be learning how to find the local extreme of a function. So in order to find the local extreme of a function, we need to find the critical points, and the critical points are located at where the derivative of the function is equal to 0, and then we're going to test those critical points using the first derivative test in order to see if they are local extreme and what type they are. Alright, so our first step is to take the derivative of the function. Now using the power rule, we know that x to the first power is just going to be equal to 1 because we're going to bring the 1 down, and that's x to the 0, so it's 1 times 1. Okay, and now the 1 over x, you can also use the power rule because this is the same as x to the negative 1. So we're going to bring down the negative, and then we're going to be left with x to the negative 2, which is going to be 1 over x squared. So we have 1 minus 1 over x squared as our derivative. Alright, so now we're going to need to set the derivative equal to 0 to find our critical points. So we have 1 minus 1 over x squared equals 0. So if we subtract the 1 over, alright, and then we know that the negatives are just going to cross each other out, so we have 1 over x squared is equal to 1. Now the way I would solve this is I would just see this as 1 over 1 and cross multiply the x squared, so I'd be left with x squared equals 1, and then you know that x is equal, once you take the square root of each side, x equal to plus or minus 1. Alright, so now we have our critical points. And now we just need to test them to see if they are local extreme and what type they are. So the way we do this is the first derivative test, and that involves a number line in which you have your 2 points, negative 1 and 1, and we're going to test values to the left, in between, and to the right of these in order to see what is going on with the derivative, if the function is increasing or decreasing. So for negative 1, I'm going to use something to the left of it, so I'll say negative 2. And I'm going to plug that back in to our derivative. Alright, so if I plug negative 2 into the derivative, I'll have 1 minus 1 over negative 2 squared, which is going to be 1/4. So 1 minus 1/4. And you actually don't really need to know the value. All you need to know is whether it's going to be positive or negative, because that tells you all you need to know, whether the function is increasing or decreasing. So 1 minus 1/4 is going to be positive. So you just put a plus here, so you remember that the function's increasing here. Next, something in between negative 1 and 1. So we can use 1/2. So if I used 1/2, I would have 1 minus 1 over 1/2 squared, which is 1 minus 1 over 1/4, and that would be equal to 1 minus 4. And 1 minus 4 is negative, and like I said, we don't care about the value, all we care about is the sign, so that's going to be negative. And now something to the right of 1, we can use 2. 1 minus 1 over 2 is going to be 1 minus 1/4, which again is going to be positive. So for negative 1, our function is increasing and then decreasing because the derivative is positive and then negative. So this is what we call a local max. And then for 1, our function is decreasing and then increasing. And then this is what we call a local min. So we have a local max at x equals negative 1 and a local min at x equals 1.